Hello, this is Nikhil from Engineering Physics third year. Today I am going to present a PPT on wearable wireless health monitoring patches. This is going to be our outline for the PPT. First, we'll go through the introduction and the drawbacks of the traditional systems. Then the main objective of our PPT, about the sensors used in detail, and then the block diagram and the working of the system. Then we'll compare the wearable patches to the traditional instruments, and finally we'll see the challenges and limitations of the wearable health monitoring patches. Introduction to wearable wireless health monitoring patches. Wearable wireless health monitoring patches are an innovative technology revolutionizing the field of healthcare and personal wellness. The discrete and flexible devices are designed to be seamlessly integrated into our daily lives, continuously tracking the essential health metrics and relaying the data wirelessly to our smartphones or other connected devices. By providing real-time insights into our physiological condition, these patches empower us to better understand and manage our overall well-being, enabling proactive steps towards improved health outcomes. The drawbacks of the existing system: they are bulky stationary devices that restrict the mobility, which are inconvenient for continuous monitoring and active lifestyle. These have complex user interfaces and specialized training required, which may be very much challenging for the elderly and those with a limited technical expertise. These are highly costly. This is a barrier for adoption, especially in developing regions and low-income communities. There's a lack of seamless integration with other medical devices or electronic health records, which hinder the healthcare provider's ability to access and interpret data. Here, the data plays an important role. Limited battery life and frequent charging or component replacement is required, frustrating for users and restrict the continuous monitoring capability. The main objective. Here, the main objective is to enhance patient results. That is, the goal is to use this continuous remote monitoring to catch potential health issues early on, before they escalate into more serious problems. This can enable fast diagnosis and treatment, leading to better patient outcomes and reduce healthcare costs. By keeping a close eye on patients' health, these patches can help prevent unnecessary hospitalization and complications. Next, increase mobility and independence. Rather than being tied to a hospital equipment, patients wearing these wireless patches can maintain their mobility and independence. They can go about their daily activities while still having their vital signs monitored. This can have a positive impact on both the physical and mental well-being, as patients don't have to feel confined to a hospital setting. Next, this simplifies the remote care. The wireless health patch-based design of the system makes it easy to implement remote care and telehealth solution. Healthcare providers can monitor their patients' health data in real time, regardless of the patient's location. This allows for more proactive, personalized care that isn't limited by geographic constraints. Physiological parameters be measured by wearable patches. Wireless health monitoring patches are designed to continuously track a variety of physiological parameters to provide a valuable insight into an individual's health and well-being. These patches leverage advanced sensor technology to measure a wide range of vital signs and biometric data, enabling comprehensive and real-time monitoring of wearers' physical health. These are health rate, heart rate monitoring, pulse rate, oxygen saturation measurement, respiration rate monitoring, and body temperature. Now we'll go through all the sensors that are used. First one is the temperature sensor. Thermistor and IR sensors are popular for measuring the skin temperature in wearable patches due to their compact size, low power usage, and suitable for continuous monitoring. As we have seen in the experimental labs, we tried to measure the temperature using both the thermistor and IR sensor. Accurate temperature tracking can be done using these sensors. These sensors detect even the slight temperature change, offering early clues to fever, infection, or other health issues. Continuous monitoring enables promote identification of concerning trends along timely intervention. No invasive monitoring. Patch-based sensors simplify adhere to the skin surface, facilitating uninterrupted 24 by 7 monitoring without disturbing the patient's daily routines or sleep. There is a wide range of wide temperature range that can be measured using these sensors, as the sensors can be calibrated to detect a broad spectrum of body temperatures, ranging from hypothermic lows to febrile highs. This extensive range enables close monitoring of patients with thermoregulatory disorder and those recuperating from illness or surgery prone to temperature variation. Next is a heart rate sensor. Heart rate sensors are critical components in wearable wireless health monitoring patches, enabling the continuous tracking of the user's heart activity. These sensors leverage advanced technologies to accurately measure the user's pulse and heart rate, providing valuable insights into their cardiovascular health. The first is phototheismography (PPG), utilizes light to gauge blood vessels activity under the skin, typically employing green or infrared light or better penetration and minimal interference from the surrounding light. They are favored in wearable for their compact size, low energy consumption, and ability to continuously monitor heart rate without skin contact, making them ideal for applications in fitness tracking and health sleep monitoring. We can see we have seen there are a lot of wearable watches which use this sensor to measure the heart rate. The next sensor that can also be used for heart rate measurement or pulse measurement is electrocardiography, ECG or EKG. This is widely used. This detects the heart's electrical activity by capturing its minute electrical signals during contraction. Renowned for its accuracy, excels in identifying irregular heart rhythms like arrhythmias. Often requires direct skin contact, may not be suitable for prolonged continuous monitoring due to the energy consumption and comfort concerns. These are widely used in medical grade variables for cardiac diagnosis and monitoring, as they need extremely accurate measurements. By continuously monitoring these electrical signals, ECG sensors can detect and alert healthcare providers to potential irregularities in the heart rate, which can be due to their heart-related issues. Real-time data for crucial for early diagnosis and intervention, enabling timely and personalized care to patients. The next sensor type is oxygen sensor. Blood oxygen sensors are used in wearable wireless health monitoring patches, typically utilize photothermography PPG technology, as we discussed earlier, for the heart rate sensor. PPG sensors also work as by emitting light into the skin, usually through LEDs, measuring the amount of light that is absorbed or reflected by the blood vessels. The change in the light absorption or reflection corresponds to the variation in the blood volume, allowing the sensor to indirectly estimate the oxygen saturation levels. These are reliable as they are established principles of light absorption and reflection, extensively validated for measuring the parameters like oxygen saturation. They are accurate, they can be properly calibrated for offering clinical, meaningful, and comparable estimates of the blood oxygen saturation to traditional pulse oximeters. They are precise and they can produce a repeatable results over multiple measurements, enabling reliable monitoring of oxygen saturation trends. They are efficient in power consumption and data processing, enabling integration into compact, lightweight wearable devices for continuous monitoring. They are sensitive to change in the blood volume, effectively detecting the variations in blood oxygen saturation levels and capturing subtle physiological changes. Here is the diagram of how PPG sensors are worked. I mean, can be used. Here, as we see, the light falls on the blood vessels and then get reflected and detected by the photodetector. And here is the electrical circuit that is used in PPG instruments. Coming to the last sensor, the respiratory sensor. Here we use a capacitive sensor. The sensor it is designed in such a way that as the lungs contract and expand, the length of the distance between the capacitor plates changes. This produces a capacitance. This produces a signal that can be sensed and converted into electrical signal proportional to the respiratory movement. Signal processing algorithms are then employed to analyze these signals and extract the relevant respiratory parameters such as respiratory rate, tidal volume, and respiratory patterns. Advantages: it is a non-invasive. Capacitive sensors are non-invasive and do not require direct contact with the skin, making them comfortable for long-term monitoring. They are very much sensitive to subtle change in chest movement, allowing for accurate detection of respiration, low power consumption, and they are robust to motion and environmental disturbances, ensuring reliable performance during the various activities. Here we can see how we can see the sensor diagram and how it is used to measure and the output signal. There is this is an athlete who is performing a physical activity and using capacitive sensors. The heart rate, respiratory rate is measured, and here is the final output that is generated, where there we can see the capacitance changes as the athlete breathes. This is a block diagram of our wearable patches. The sensory information is passed to a microcontroller. Then this information is then processed and passed to the IC and then to a GSM SIM module, which can be used to transmit the data to our mobile device using certain algorithms. This is a pin diagram for our microcontroller, which is a single chip microcontroller. And this is the pin diagram for our IC, which is an integrated product that converts signal from the microcontroller to a compatible digital logic circuit. And then this is our GSM SIM module, which is module is a chip that or a circuit that will be used to establish a communication between a mobile device or a computing machine and the GSM or GPS system. Comparing wearable patches to traditional instruments, continuous monitoring can be made using these patches, which provide a real-time monitoring of vital signs and health data, allowing for timely intervention. They are reliable, hence enhanced reliability is achieved through redundant sensors and robust wireless connectivity, reducing the risk of data loss or interpretations compared to the traditional wired instruments. They can be reproducible and less susceptible to human error or inconsistencies associated with manual measurement, improving the reproducibility of the measurement. As the sensors are advanced, they are accurate and precise, surpassing traditional hospital equipment. They can be a superior alternative because of the latest advancements in wearable technology and wireless communication. These patches offer a superior alternative to traditional instruments, leading to more effective, reliable, and precise patient monitoring and care. Challenges and limitations of wearable patch technology. Challenges may arise in maintaining high accuracy and reliability, especially during intense physical activity or in environments with motion artifacts. Balancing continuous monitoring with battery longevity is crucial and requires efficient power management strategies. Sensory integration of multiple sensors into a small form factor while minimizing cross interference and maximizing accuracy is technically challenging. Ensuring comfort for extended wear is vital, requiring careful material selection and form factor. Robust measures are necessary to protect sensitive health data from unauthorized access or breach. Cost effectiveness and accessibility are a barrier to widespread adoption, particularly in resource constrained settings. Meeting regulatory requirements such as FDA approval is challenging and essential for market entry. This is all about wearable wireless health monitoring patches. Thank you.